Hello students, after a short break, I thought that let me come back on my passion, the passion of teaching and speaking and learning, back on my channel, The Science Geek. So I had taken a small break because I'm out of India with my daughter in Amsterdam. So I thought, but I love teaching, so I could not stay without making a video. So this is a small video. I don't have much things here, but I will make the things very clear to you all. It's this time focused on CBSE, and the lesson goes as metal, non-metal. Okay. Previous to this, I had posted for CBSE the lessons. Just recapitulating, it was acid, base, and salt, and then I had done for them chemical control and coordination. Then also I had done heredity part I had done, and after this I didn't do. Then I shifted to ICSE. So welcome to the new students and the students who will see it again, and to the old subscribers. So as Ganesh Chaturthi is going on, Vignaharta, so let him this year remove the obstacles of from everyone's life, and the students must be preparing for their forthcoming exams as the time is running. And tentatively the CBSE has given also the date for the board as 15th of February, with so many questions, so many types of changes which they have made in the paper pattern, case study, assertion reasoning, whatever it was at the previous one, then the short answers, long answers. So the total mode of the paper is now changing. So the lessons remain the same, but the way you will study for your exam, your approach towards the lesson, that has to change. The lesson is the same, but you have to always keep a pen and a notebook with you, to write down what you are learning, because I have always told this, that a lesson is learned by reading, writing and speaking. So welcome to the CBSE lesson of metal and non-metal. Okay, now this whole lesson, metal, non-metal, will be divided into parts. Now you should recapitulate what you had done in your 8th standard on this lesson, metal, non-metal. For you, in this lesson, first part of the lesson is about just the physical properties of metals, like which you had learned before. Like the metals are sonorous, the metals are malleable, the metals are ductile, and the other properties like good conductors of heat and electricity. All this with the activities given in your NCERT book, the experimental verification for them, and in parallel to comparison with the non-metals. How are the non-metals as compared to the metals with the physical properties. Then comes the chemical properties of the metals to that of the non-metals. After this comes that how do the metals and the non-metals react. The ionic bonding, very important. If you had seen the lesson of one lesson which I had given on chemical bonding, where I had told you about covalent bonding, ionic bonding. So here the emphasis will be on ionic bonding, okay? And in your book they have shown the ionic bonding of NaCl, the best example, and magnesium chloride. Apart from that, you have to practice the steps of formation of an ionic bond between a metal and a non-metal. After that comes in the last part of the lesson, and this goes with the electronic dot structure of or Lewis structure of that metal and a non-metal. Then comes the properties of the electrovalent or ionic compounds, which has been listed in your book. How the ionic compounds are having their various properties. Okay. Now after this also comes a very important thing, how are the metals extracted. And before the extraction of metals, you should know about the reactivity series. The reactivity series of metals, very important, because that is the base for the displacement reactions which you did in your 8th standard, and try to recapitulate the displacement reactions. And also in lesson number 1 of your 10th standard CBSE, you did different types of reactions. Just recapitulate, because all the lessons are interrelated. Chemical reactions, acid, base and salt, metal, non-metal, till carbon, which is exclusively an organic chemistry lesson. So here displacement reactions is very important. It is based on the principle of reactivity series, and in that reactivity series you have to learn it, the most reactive, the moderately reactive and the least reactive. Least, moderate, the least reactive are the placed at the bottom, which are the noble metals. The highly reactive metals, the potassium, sodium at the top, and that's why they are stored under kerosene and water. If to recollect. That is the reason, because they rigorously catch fire once they are exposed to air. And then the moderately one. Okay, so and in this also comes how some of the metals react with cold water, some with steam, and some doesn't react at all. And which are the noble metals like the gold, silver, they don't react at all. This is that part, reactivity series, which you have to keep in mind, very important. And lot of case study questions, assertion reasoning is asked on this part of the lesson. And the last part comes the extraction of the metals, that is metallurgy. Okay, based on this reactivity series is the metal. How is the metal extracted from its raw form, that is the ore. So that three types will be there: least reactive extraction, moderately reactive extraction, and highly reactive extraction. Okay, so this you will study. And in the last part of the lesson is corrosion of iron, and how corrosion can be prevented. And this little bit you have studied in the first part, but this is the last part of your inorganic chemistry. So here you will be doing this part. Also you should know about alloys, what are the types of alloys, preparation of alloys, and what are the objectives of alloys making. Okay, so it's a very nice lesson and a very interesting lesson. So keep your notebook and pen ready with you. I don't have a whiteboard here, but I could not stop from making a video, so I have just started with it. So during the days of Ganpati, so that the CBSE students are enriched with little bit with this small LMR last minute revision which I have given to the name of my videos from this video. Okay, so let me wish everybody happy Ganesh Chaturthi. As this is going on, today is the third day. May you all must be celebrating it with pomp and show, but little studies is important. So with this, Vignaharta, Vakratunda Mahakaya, Surya-koti Samprabha, Nirvignam Karume Deva Sarvakareshu Sarvada. Let him bless you and let him bless me also, so that I can flourish in this line of video making and spread to the children. Welcome back to my channel, The Science Geek. Now please keep your CBSE book open in front of you. Now the first part of the lesson is how do we classify the metals. The classification of the classification of elements into metals and non-metals. Okay, and also the word metalloids will come here. So what will you write for what is the basic definition of a metal? How will you define a metal? A metal is defined as the element which possesses luster. First point, luster. When freshly cut, they are malleable, they are ductile, they are good conductors of heat and electricity. One part of the definition. Another part of the definition is they are also defined as the elements which give away electrons and form positive ions. That is, they form cations like magnesium or sodium or calcium. Any example you take, sodium has valency as 1. Why? Because atomic number 11, 281. So when it will give away 1 electron, it will form a cation, Na+. Magnesium will get a valency of 2. Atomic number 12, 282. So 2+. Like this, the series goes on, which you did in 9th standard, and try to recapitulate it now. Okay. So sodium, potassium, magnesium, calcium, aluminium, copper, all these are metals and with their valency. And the inert metals are gold, silver, platinum. Okay, they are the inert metals. Now what about a non-metal? What is a non-metal? A non-metal is defined as those elements which don't possess luster, they are not good conductors of heat and electricity, and they are non-malleable, they are non-ductile, and also non-sonorous. They lack luster. This is a non-metal, one part of the definition. The another part is they are also defined as those elements which gain electron. Metals lose electron and the non-metals gain electron. With this concept only, the electronic dot structure or the Lewis structure of sodium chloride is given in your book. Losing and gaining. A partner will lose electron, the another partner will take the electron. So both of them will form an ionic bond or electrovalent bond. It is there in your portion now. So they gain the electron and they form an anion. Example here is chlorine. Chlorine is like atomic number is 17. So the electronic distribution is 287. So 287. So this 7 is, it needs one electron. So from where will it get? It will get from its partner sodium. And from sodium, when it will get, it will form an anion, Cl minus. So the non-metals are electron gainers and the metals are electron givers. The metals are also electropositive in nature and the non-metals are electronegative in nature. Basic difference, metal, non-metal. Okay. So the other examples of non-metals are hydrogen, oxygen, nitrogen, sulfur, which you did in your 8th standard, phosphorus. These are all the non-metals. Now, third category of elements which you should know is metalloids. The metalloids are those which share the properties of metals and non-metals both. Okay, they share the properties. And what are the elements under this? The elements are silicon, germanium, antimony, tellurium. These are the examples of metals and non-metals sharing the properties of both. And in the periodic table, they are placed in a zigzag manner between the metals and the non-metals. The metals are on the right hand side of the periodic table and the non-metals are on the left hand side. So between this metal and non-metal are the what if you have seen the periodic table, I had given one video on periodic table also, are the metalloids. This is this. Then comes, you should know, if they ask you for 2 marks, 1 mark question, what is the importance of metals and as compared to non-metal. So you should write some important points like the metals are used in construction of buildings, bridges, they are made for making and manufacture of automobiles, aeroplanes, like also they are made at home we use the metals like aluminium, copper. If you see, the utensils are copper plated, right? And we use aluminium. Why? Because copper is a very good conductor of heat. Okay, this, okay, like silver is used to make jewelries. You should be pinpoint and write the important uses of the metals. Not all the metals which are highly used in the industries, like chromium for electroplating, right? Then copper, aluminium, all this you should focus. Don't give on the general if they give you. Then comes the importance of the non-metals. If they ask you why the non-metals are equally important as compared to the metal. The non-metals are, although the number of non-metal is small as compared to the metals, but they play a very important role in our daily life. Now how, if they give you this question, how this can also come in assertion reasoning. Non-metals play an important role in our daily life. Assertion, reasoning. The reasoning can be given like the carbon is used as a non-metal for our daily compounds like carbohydrate, protein. So what will be the answer? The assertion is also true and the reasoning is also true. So I give you the first example here. Carbon as a non-metal plays a very important role in carbohydrates, proteins and vitamins, enzymes, etc. Also, another 2 forms of carbon, the graphite is used as electrodes. A very important form of carbon is graphite, and graphite is brittle in nature. Carbon exists in 2 forms, allotropic forms, diamond and graphite. Diamond is the very good conductor of heat, and diamond is very the hardest substance known, and graphite is very brittle if you compare. Diamond is having a tetrahedral structure and graphite is having a structure which is, if it forms a layer, one layer above the other. That's why it is used as an electrode in electrolytic cells. This is the reason for the structure of graphite. Okay, and graphite is an allotropic form of carbon. Then another important non-metal which is used in our life is hydrogen. Hydrogen is found in all the compounds and also the rocket fuels and the vegetable ghees and all. Hydrogenation of vegetable oil is done. An important reaction is there in carbon where you will see large amount of hydrogen is added. Okay, and we call this as hydrogenation of vegetable oils to make vegetable ghee, oil to ghee. How? Hydrogen is added. And a reaction is there, addition reaction, and you will see how oil to ghee is converted from vanaspati oil to ghee due to hydrogenation of the oil, non-metal ka use. First I told about this one, graphite. Second important non-metal you should remember is hydrogen. And third is oxygen, obviously a non-metal, always used for breathing. And the fourth one is another important non-metal used in our daily life is the nitrogen. which is, if you remember your 8th standard nitrogen cycle, a non-metal used in its gaseous form. Okay, it is also this nitrogen, it reduces the rate of combustion. Therefore, nitrogen is used in the manufacture of ammonia, nitric acid, and fertilizers. Okay, so nitrogen is very, very important, and nitrogen is also used to preserve food. Okay, so the 4 important non-metals, right? This comes the metal to that of non-metal. Now, another thing is a very small 1-mark question which can be asked to you is, what properties of metals make them so useful? What distinguish between the properties of metals and non-metals, and categorize them based on their physical properties. So this you think, which property of metal makes it very useful, you think, and distinguish the properties of metals and non-metals based on the based on their usefulness, and also based on their following chemical reactions. How do we distinguish between the properties of a metal to that of a non-metal? Okay, now first thing here is, we will come to the physical properties of the metals. Keep your NCERT book in front of you. Now the first part is, the metals is in pure state possess luster, shining nature, right? So for example, you must have seen magnesium ribbon in your chemistry lab. So this magnesium ribbon is often rubbed with sandpaper. Why? Because if you take few examples of few metals like iron, copper, aluminium, magnesium, you note their appearance. All these things are there in the lab. Aluminium turnings are there, copper wire is there, magnesium wire is there, and rusted and iron filings are there. So you have to clean the surface of these metals by rubbing with a piece of sandpaper, because when they are exposed to air, moisture comes on them, you cannot see their shining surface. So then the surface of most of these metals becomes dull when it is exposed to air for a long time. So, and thus it is due to the attack of the gases of the air on the surface of the metals, forming thin layers of oxides, carbonates, sulfides. So what does this air does, moisture does? It forms these layers of oxides, carbonates, and sulfide. To remove all this, we rub it with the sandpaper. So what is the role of sandpaper here? This is the role of sandpaper here. Now, so that was the first property. Then metals are having luster. Second is, metals are generally hard, and the hardness varies from one metal to the another metal. Okay, say you take few metals like iron, copper, aluminium, magnesium, and try to cut them with knife. Which one will you observe? You can cut more easily. Okay, like for example, some metals like lithium, sodium, potassium are the metals which are so soft that they can easily be cut with a knife. And for this reason, where is sodium stored? Just think where it is stored. Take a piece of sodium metal from kerosene oil and then remove all the excess oil from the filter paper, and you can cut it. Sodium pellets are seen in the lab, and that's why we say that the hardness of the metal varies from one metal to that of the other. Okay, so the hardness. Then next comes, the metals are malleable. All this was told in your aid, recollecting you these main properties. Metals are malleable, that is, they are broken or beaten into thin sheets. Like the experimental verification, because in this part of your lesson you have to study the property with the experimental variation. Like that, you have to keep the mind, those experiments in your mind. Which experiment or activity is given in your book to support that physical property or the chemical property of the metal or a non-metal. So the experimental verification for malleability is, take pieces of metals like iron, copper, zinc, lead, place them one by them on a block and strike the pieces with a hammer, right? Now it is observed that the pieces of the metals, they change their shape. The same result is observed for beating the metals with hammer, and this property of beating with hammer and forming thin sheets is known as malleability. And this is also industrially it is used in the where the metals can be broken into thin sheets. Next is, they are ductile in nature, ductility, that is drawn into thin wires. Like the wires of copper, you must have seen, wires of aluminium, you must have seen. So this is all because these metals can be drawn into wires by the property of ductility. Okay, and one of the most interesting fact here is, gold can be drawn into a wire of about 2 kilometer length, and it is so much, that's why metal of high which is used highly we use it, right? And All these will be your assertion reasoning questions. Next comes the property of malleability, ductility told you. Now we come to the some of the properties of this. If they ask you, give some specific properties or applications of malleability and ductility of a metal. Specific properties, what will you give there? What will be your answer there? You should say sheets of irons, copper, aluminium are used in making vessels, and also they shape the bodies of the automobiles. First property this. Second is silver foils are used for decorating the sweet. You must have seen, now you must be eating sweets at home, how the silver foil or aluminium foils to keep the thing warm. Okay, then comes aluminium foil are used for wrapping medicines and for your chocolates, etc. And these are the uses of these metals in your everyday life. Then if they ask you, name 3 metals which are used in an everyday life with their specific use. First use can be silver, next can be aluminium, and third can be copper and copper, because copper wires are used for transmission of electricity, and copper is very good conductor of electricity. Got it? This is the very important physical property. Next is, if I ask you, give an experimental verification that metals are good conductors of heat and they possess high melting point. This activity is also given in your book, where you will take a thick copper wire or an aluminium wire and you clamp it horizontally and then fix a pin and on a burner, try to heat it, and then you will see it is observed that the wax melts and the pins fall. This shows that the heat flows from one end of the metal to the other end. If you take a metal wire and you clamp it, put a burner below it and you try to heat it, you will see the wire does not melt easily even after long heating. This shows that the metal possesses high melting point, because the whole activity of reading it out is about you take a free end of a wire, fix it with the help of a wax on a stand and heat it, and after that you will see that the wax will bend, melt and fall, but the wire will not melt, because this copper is a very good conductor of heat. Okay, but with exception, some metals have low melting point. Now which are those? Lithium, sodium, potassium, cesium, gallium. These 1 mark questions they ask. Name the metals which have low melting point. So lithium, sodium, potassium, cesium, gallium are the metals which have low melting point. In fact, gallium and cesium have so less melting point that they melt even on your palm. They start melting even on your palm. So you have to be very careful with them. So, and in this, silver is the best conductor of heat. Copper is the second best conductor. If you arrange them in a series, silver is the best, then copper. And for this reason, we use the cooking vessels, and the water boilers are made up of copper and aluminium at the base. Our full aluminium container is also there. And among metals, the metal which is the very poorest conductor is lead. Lead is the poorest conductor of heat, and then mercury also, very poor conductor of heat. So you should learn this lesson with from objective point of view, from subjective point of view, and from writing very short answers to answer the case study questions, to answer the multiple reasoning. So you have to study, read a lesson from many angles. From many angles you have to read. So for that, always keep on writing what you are reading. Okay, that's what I'm saying. And as many examples you learn, that much you can be able to recollect and write. Okay. Now the next experimental verification comes for the metals are good conductors of electricity. Now you must have read in your 7th standard, 8th, that electric circuit, how we make an electric circuit. To see the conductivity of different metals, the first metal will be silver. If you arrange them in a series, silver, then copper, then gold, silver, copper, gold, then aluminium, then tungsten, then mercury. You should learn this series. I repeat it. Silver is the best conductor of electricity, where mercury is the purest conductor of electricity. What is the reason? Because it offers very high resistance to the flow of electric current. The word resistance is the key word here. The series is silver, copper, gold, aluminium, tungsten, mercury, and silver is the best, mercury is the purest. The reason is silver offers very high resistance to the flow of electric current. And why copper and aluminium, being cheaper than silver, are also used for making electric wires, because silver is very costly. Okay. Now the covering of the wires you must have seen with the plastic like why the wire, and that is why these wires are covered with the plastic. One answer question: what is the name of that plastic? PVC, polyvinyl chloride. PVC is done because it acts as an insulating material to protect you from electric shock if you touch the wire accidentally, and also the electric current flows in the wire. So why the metal wires are coated with a plastic covering, and what is the name of the plastic covering? PVC. Got it? PVC. Now points to remember here, another point here is, if they ask you a hot question, that how do the metals conduct electricity? What is the reason behind it? That the metals are good conductors and the non-metals are not the good conductors. So what you will tell here, the conduction of electricity by metals decreases with increase in temperature. This is because metal atoms consist of free electrons. The electrons are moving, okay, of the valence shell. They are moving in the last shell, and the remainder positively charged part, the inner part, which is the nucleus part, that is known as the kernel, KERNEL, and the electrons are rotating in the valence shell, and especially the last one. The electron which is rotating in the last shell is the valence electron, and that is only which is most important. And with the increase of temperature, what happens? The kernel starts vibrating. Vibrating means the positively part of that element starts vibrating, creating hindrance in the flow of electron. That is why the conduction of electricity by metals decreases with increase in temperature, because here the positive part of the metal comes into play. It starts vibrating and it creates a hindrance on the flow of electrons, and thus the electrons cannot flow freely, and thus the metals cannot conduct electricity at a very high temperature. A very important question. Okay, next comes they are sonorous, like you must be hearing the school bell. You must be waiting for your tip when the school bell rings. That is, they are sonorous. Next comes metals have high density, except with the exception lithium, sodium, potassium have low. So you should learn these exceptional properties. Always the general properties, with that the exceptional properties. Okay. Next is they have high tensile strength. The tensile strength means the strength with which they hold something. So it is due to this property that the iron is used for construction of bridges. If they ask you why iron is used for construction of bridges, buildings, railway tracks, machinery, the key word here will be they have high tensile strength. Tensile strength is the key word here. They have high tensile strength. Okay. Now, next is, and the last one physical property is, all the metals are solid with exception, except one metal, that is mercury. And that is the mercury is used in thermometers. Okay, now tungsten has high resistance and high melting point, and thus it is used for making filaments of lamps. If they ask you, give the role of tungsten, give two specific properties of tungsten, you should just write high resistance, high melting point. Thus it is used in making lamps. So till now I was discussing, gave you the overall description of the lesson, gave you the physical properties of the lesson with the small experiments in mind. Okay, next 10 minutes I will go for the physical properties of non-metals, revising you in tips last minute. I don't have a blackboard here, but I hope you will cooperate with me, because I am trying to explain you the basic funda, the basic concept of the lesson. Okay, the pink pen is non-metal and this brown pen was metal. So I finished with this brown pen. Now I hold in my hand the pink pen. Okay, so what is the properties of a non-metal? Non-metals don't possess luster except iodine, okay, which is a non-metal but it is lustrous. First property. Second, they are soft and brittle. They break into pieces when they are hammered. The only exception is diamond, which is very hard and it is an allotropic form of carbon, as I told you, and it is the hardest substance known in nature. Exception properties. Third, they are non-malleable, non-ductile, okay, but brittle like graphite to some extent. Third, they are bad conductors of heat and electricity, with exception graphite, an allotrope of carbon and is a non-metal but a very good conductor of electricity and thus is used in making electrodes. This will be a reason. Short answer question, even for assertion reasoning. Okay. Now, due to the absence of free electrons, In them, the free electrons are not found in a non-metal. So that's why they cannot conduct electricity except graphite, which has free electrons. Okay. Next is they are non-sonorous. They will not make any noise. They won't be able to produce any noise when they are hit along a surface. Next is they have low melting point and low boiling point, with exception boron, diamond and graphite, which are non-metals. Boron, diamond, graphite, which have high melting point and high melting point. Okay. Next is non-metals have low densities. Matlab they are light elements. Okay. They are light elements. Okay. Now also they have low tensile strength. They are easily broken. But a metal will not be broken, like iron bridges. It will not be broken that easily as a non-metal will be broken. The next is they are solid, liquid or gaseous at the room temperature. For example, carbon, sulfur, phosphorus, iodine are the solid non-metals. Bromine is a liquid non-metal. Hydrogen, oxygen, nitrogen and chlorine are the gaseous non-metal. These questions are usually asked. Name a non-metal which is solid, name a non-metal which is liquid, name a non-metal which is gas. So you should keep this answer ready with you. Okay, so physical properties of metal to the physical property of the metal to that of a non-metal. Metal on the right hand side of the periodic table, they are electron losers, they are electropositive. Non-metal on the left hand side of the periodic table, they are electron gainers, they are electronegative as per the definition which we were going on. And as we proceed from left to right, from a metal to a non-metal, in between comes the zigzag pattern, comes the metalloids. Okay. Now we will go with just in 10 minutes I will go with try to go with the chemical properties of, because this is a last minute revision for you, of the metal to that of a non-metal. Okay, the chemical properties. Now, first chemical property which you will learn and which you should write in your book is the metals form oxides. We have been learning this from your 8th standard. Metal forms oxide and even a non-metal form oxide. So the nature of the oxide and how they form the oxide. The metal forms oxides which are basic in nature, and the non-metal form oxides which are acidic in nature, and or they can also be neutral. Okay, so you should do this in a tabular form, the chemical properties of a metal to that of a non-metal. Okay, now the experimental verification for this is you will take magnesium, you will write the reaction. 2 Mg plus O2 forms magnesium oxide, and this magnesium oxide when reacted with water, MgO plus H2O will form magnesium hydroxide. Okay, and this is an example of metal. If I want to compare this with sulfur, I will tell, if you remember the sulfur, the deflagrating spoon, 8th standard, S plus O2 forms SO2. Then this SO2 plus H2O forms H2SO3. So sulfurous acid. Now, if I will bring litmus paper, test of litmus paper, this litmus paper when it will be brought to this, to this magnesium oxide or to this sulfur dioxide which is forming sulfurous acid, the litmus paper will change its color because one will be basic, the another will be acidic. Basic is metal and the acidic is non-metal. Okay, so the combination of magnesium with oxygen forms magnesium oxide. This magnesium oxide can be termed as X plus water forms magnesium hydroxide, which can be Y, and like that they can ask these questions in high order thinking, these questions, and this you have to draw and understand, and how you will draw and write and understand what is X, what is Y, and which is basic, which is acidic. Like that, sulfur with oxygen forms sulfur dioxide with water forms sulfurous acid, which is acidic in nature. Okay, that is the first property, the nature of oxide, basic versus acidic. Next is the word ionization energy. If they ask you what is ionization energy, ionization energy is the amount of energy required to remove the electron from the valence shell or the outermost shell of an isolated gaseous atom so that it can be converted into a positive ion. Very important. Okay, and this, based on this ionization energy, the cations are formed. Like sodium. How much ionization energy is required to remove that valence electron from its outermost shell? okay, to form a stable one. Okay, so like this, and this is known as ionization energy if they ask you. Then they have, based on this, the reactions are there. Then the another is they have high tensile strength, and as I told you, and the chemical properties of these metals, non-metals, are so important that you will see them in your reaction form. So the chemical properties of metals, I told you, ionization energy, which I told you, and for this, if you have to write the three reactions. Sodium first, it forms Na plus an electron or valence electron, it loses one. Magnesium forms Mg1 plus 2 electrons. Aluminium forms aluminium 3 plus 3 electron. So they are all electropositive in nature. Due to their electropositive character, they have a number of characteristic properties. The best three metals taken here is sodium, magnesium, aluminium. Okay, sodium with valency 1, magnesium with valency 2, aluminium with valency 3, and their ionization energy. Now, and with this, they are important in your everyday use. Next is the metals react with oxygen to form what? They react to form metal oxide. That is how they react. How do the metals react? For this, you can form burning of a magnesium wire with oxygen, copper with oxygen, lesson number 1, copper oxide, chemical reaction, the vessel becomes black. All the lessons are interrelated. So the reactions of magnesium with oxygen, atomic number 12 has magnesium electronic valency 282. It loses 2 electrons to form Mg2 plus. Oxygen atom with oxygen number 8 has electronic configuration 2,6. It gains the 2 electrons to form an oxide ion O2 minus. So Mg will first valence Mg, you will write Mg, magnesium. You will write the atomic number 282 arrow. Then you write Mg2 plus 2 electron, because then the valency becomes 28. Then where will this 2 electron go? This 2 electron will go to oxygen because it has valency, it is having atomic number 8, so its distribution is 2,6. So O plus this 2 electron which magnesium loses will combine to form oxide O2 minus, and oxygen will be stable 2,8. And then the final reaction, Mg2 plus O2 minus, magnesium ion plus oxide ion forms Mg2 plus O2 minus, plus minus cancel, 9 standard valency cancel, formula is MgO. Okay, magnesium oxide, and the metal oxides are ionic in nature because ionic formation takes place. Got it? And now, this same magnesium oxide, when it will be soluble in water, it forms magnesium hydroxide. So this is one very important part. And second part is the metal oxides are insoluble in water, because some metal oxides like sodium and potassium, they form alkali when they dissolve in water. They can ask you how metals form alkali. Your answer should be the metals form alkali when they dissolve in water. That is N2O, sodium oxide, plus H2O forms NaOH, aqueous alkali. K2O, potassium oxide, plus H2O when dissolves in water forms 2KOH, alkali, potassium hydroxide. So this is one of the very important property of metals. They form alkalis. Second important property of this metal chemical property is they are amphoteric in nature. Some of them. Basically, metal oxides are basic, but some examples of amphoteric oxides are also there. Now, most of the metal oxides are basic. Like I told you, they dissolve in water to form alkalis, but some of them are amphoteric. But they react both with the acid and both with the base. To explain the basic nature, you will give the example of sodium. Okay, and another example which I am telling you here is magnesium oxide, MgO, plus sulfuric acid, H2SO4, forms MgSO4 plus water. Copper oxide, CuO plus H2SO4 plus CuSO4 plus water. So the metal oxides, this is how we are telling the solubility in water. They are soluble in water. Most of the metals are insoluble. Exceptions are sodium and potassium. These metal oxides are highly insoluble. Okay, and that is why they form this sodium and potassium, when they dissolve in water, they form an alkali. Then next I told you the word basic nature, that alkali test. Amphoteric nature, now telling you the metal oxides like aluminium oxide given in your book Al2O3 or zinc oxide ZnO. They are both acidic and basic in nature because they react with acids and bases both. The reaction is very important, and they form amphoteric oxides. So what are amphoteric oxides? Amphoteric oxides are the oxides formed by aluminium and zinc. The reaction given in your book, Al2O3 plus 6HCl forms A2AlCl3 aluminium chloride plus 3H2O. Next is Al2O3 with a base 2NaOH forms sodium aluminate 2NaAlO2 plus H2O. Learn the by heart it. Like that is zinc. ZnO plus 2HCl, ZnCl2 plus H2O. ZnO plus 2NaOH, sodium zincate, Na2, ZnO2 plus H2O. Okay, and further it is important to note that the different metals do not combine with oxygen with the same speed. Some metals react with oxygen at room temperature, some react with heating, and some combine on strong heating. Okay, so the fewer examples are given, like which react at room temperature, like sodium and potassium. They react at the room temperature. That's why you have to keep them under kerosene and water. This is the reason why we keep them. Next is why the metals like magnesium, aluminum, zinc and lead, they also combine with oxygen at air to form an oxide, but their reaction is much slower as compared to sodium and potassium. So they form a protective layer over them. Which three metals? Magnesium, aluminum, zinc and lead. Now further is on heating magnesium on air, the dazzling white light is produced. What is that powder called as? Magnesium oxide. 2 Mg plus O2, 2 MgO, white powder. This shows that magnesium is more reactive than aluminium, zinc and lead. This comes in your case study question. They will give you a paragraph where they will tell, find out the metal which is most reactive with oxygen. So the most reactive metal will be magnesium, then aluminium, then zinc, then lead. And for this then they will give you a case study question. Now next is iron. Iron does not burn in air even on strong heating, but begins to glow with the light, and at high temperature it combines with oxygen to form iron oxide or a magnetic oxide of oxygen of iron, which is given by the formula Fe3O4, which is a mixture of FeO and Fe2O3. So iron plus oxygen, if they give you write the equation, you will write 3Fe plus 2O2 on heat, it forms Fe3O4. Next is copper. Copper also does not burn in air even on strong heating. Name two metals which doesn't burn in air, iron and copper, and give the reaction, telling you the reaction. 2Cu plus O2 forms copper oxide. That activity was there in lesson 1. And then and on prolonged heating, it shows copper is less reactive than iron. Iron is very reactive. Next is silver, gold and platinum. Three metals. Many examples are there in this lesson for you to learn for physical and chemical properties. Silver, gold and platinum don't combine with oxygen of the air even at high temperature, and it shows that they are least reactive and they are inert. Okay, now one word is there in your book. What is anodizing? Anodizing, it is given in the yellow box in your NCERT book. What is anodizing and where it is used? So with this, I will try to, the chemical properties are going ahead, many are there, but I will not go so much ahead. I will just end here. Which part? I will end till the anodizing part, or maximum I will end till the displacement reaction wala part, which is given in your book. And now I am telling you about the anodizing reaction. What is anodizing? Because I will have to recapitulate also the whole lesson for you, what I taught today. Anodizing is I am revising the lesson for you. Anodizing is a process of coating a black layer of aluminium oxide on the surface of aluminium. It protects the aluminium particles from corrosion, and the oxide layer formed on the surface of aluminium when it is exposed to air for some time. However, this thick layer of the oxide, of the oxide anodizing is done electrolytically by using sulfuric acid in an electrolytic tank and making the aluminium article to be ionized as the anode. The oxygen liberated at the anode on the electrolysis combines with the aluminium. This process is continued till a required thickness of oxide layer is formed. Another advantage of this process is that the oxide layer can be dyed to give a beautiful color to the article. So very important and short note on what is anodizing. What is its importance? Okay. Next comes we were doing the chemical properties of metals. You have to write all the chemical properties. Last minute revision, 5 minutes more. Next is reaction of metals with water. Like here, the different reactivity of metals are there. One with cold water, one with steam, and one with hot water. This is a very frequently asked question in the board exam. Comparison of sodium, calcium, and magnesium. Because some of them float, they don't dissolve. So this is a very important question. Give the metals reactivity and evolution of hydrogen gas takes place here. A number of metals react with water to form hydroxide or an oxide with evolution of hydrogen gas, but the reactivity of different metals are different. Some metals react with water at room, some on heating, and some other with steam, and some don't react with steam also. So the first metal here is combination of two metals are sodium and potassium. They react with cold water very violently, and the reaction is highly exothermic. So 2Na plus 2H2O forms 2NaOH plus H2. 2K plus 2H2O forms 2KOH. One is sodium hydroxide, one is potassium hydroxide plus H2. Next is highly exothermic reaction of two metals, sodium and potassium. Next is calcium. Calcium reacts with water at room temperature, forming calcium hydroxide, but the reaction is less violent. The heat evolved is not sufficient for hydrogen to catch fire. So Ca, calcium plus 2H2O, room temperature, calcium hydroxide plus hydrogen. The bubbles of hydrogen gas produced stick to the surface of the calcium, and hence it starts floating on the surface of water. If they ask you a hot question, why does calcium float on water? This is the reason. Bubbles of hydrogen gas is produced which stick to the surface of calcium, and it makes it float on the surface of water. Okay, and the third one is magnesium. So comparison of sodium with calcium to that of magnesium. Magnesium is least reactive. Magnesium doesn't react with cold water, it reacts only with hot water, forming magnesium hydroxide. With cold water, it will not react only. It will form only with hot water to form magnesium hydroxide and hydrogen. So it also starts floating on the surface of water due to the bubbles of hydrogen gas. So we note that with steam, magnesium forms magnesium oxide and hydrogen. Magnesium will form two things. What will magnesium form? With hot water, Mg plus H2O, 2H2O, it will form MgOH twice plus H2. Where hot water. This is with hot water. Now magnesium with steam, Mg plus H2O, that is steam, it will form magnesium oxide. Okay, hydroxide with hot, and with steam magnesium oxide and hydrogen. So experimentally, to study the reaction of metal with water, take cold water or at room temperature, and take beaker half filled, put the small pieces of the metals into it and cover the beaker and observe them by covering them. Stir it with a glass rod and see what happens. Okay, you will see that some of the metals like aluminium, zinc and iron, they neither react with cold water nor with hot water. They react only with steam. So name three metals which react only with steam. Aluminium, zinc and iron. Aluminium, zinc and iron, they react only with steam. And what is the reaction? 2Al plus 3H2O forms aluminium oxide, Al2O3 plus 3H2. Zinc Zn plus H2O forms ZnO plus H2. Iron ka 3Fe plus 4H2O steam, Fe3O4 plus 4H2. So this is the action of steam on any metal can be studied by setting up an experiment which is given in your book. So cold water, hot water, steam. Cold water, hot water, steam. With steam, three metals: aluminium, copper, and iron. With magnesium is having a combination with hot water also, with steam also. And before this, you did with this one, calcium, room temperature, sodium, potassium, room temperature. This is how metals react with water, and the reactivity of all the metals at different conditions shown to you. Now, some metals don't react with steam. Which are those metals? like lead, copper, silver, gold. Lead, copper, silver, gold. They are the metals that don't react with steam only. So the order of reactivity of different metals towards water, overall water is what? First will be potassium, then sodium, potassium, sodium, calcium, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, silver, gold. Lead, copper, silver, gold. So this is the reactivity series also. So the reaction of metals with water was very important, told you that, and also the nature of oxide, told you amphoteric oxide in water, hot water, cold water, steam, and some metals not at all. They don't react with steam at all. Reaction of metals with dilute acids comes for the displacement reaction, as I told you, and the most reactive metals, the moderately reactive metals, and the least reactive metals. So for this, the reactivity series will be told to you. And so the most reactive metals are those which react with acids to produce hydrogen gas and salt, like with all, and they all form salts. And the less reactive metals are those which don't react like with above acids to produce hydrogen. And for this, the examples are sodium and potassium react violently with acids to form chlorides, 2K plus 2HCl, 2KCl plus H2, 2Na plus 2HCl, 2NaCl plus H2. Calcium also reacts vigorously, though less than sodium and potassium. Magnesium reacts rapidly, but the reaction is less vigorous, Mg plus 2HCl, MgCl2 plus H2. Aluminium reacts with dilute hydrochloric acid slowly and in the beginning, but because aluminium is covered with the protective layer of aluminium oxide, hence after this layer gets dissolved in the acid, the reaction becomes fast and then the hydrogen gas is produced, because it is amphoteric in nature, if you recollect. Okay, like that is zinc and like that is iron. Iron reacts very slowly with acid and gives iron chloride and hydrogen. Copper, silver, mercury doesn't react with dilute hydrochloric acid or sulfuric acid. So the order of reactivity of the metals toward acid is again the same: sodium, potassium, सबसे पहले potassium, then sodium, then calcium, then magnesium, aluminium, zinc, iron, copper, silver, gold. So the order of reactivity is given to you, and alternatively, to know the relative amount of heat evolved in all these vigorous reactions, you have to measure it with the thermometer and see, and you will note that dilute nitric acid is used in place of dilute HCl in some of the cases, because dilute it is important to note that if dilute nitric acid is used in place of dilute HCl, why there is no evolution of hydrogen gas? This question is asked. Why dilute when dilute HNO3 is used, why hydrogen gas is not evolved? What will be your answer? The answer is this: because the nitric acid is a strong oxidizing agent. It oxidizes the hydrogen formed into water, and itself it is reduced to the oxide of nitrogen like N2O, NO or NO2. However, magnesium and manganese don't react with dilute HNO3 also, but they give out hydrogen gas. So, in fact, all the metals along with hydrogen have an arranged order of decreasing reactivity, which we called as a reactivity series, which I will be discussing you. And the last term here, I will tell you about what is aqua regia. That is the mixture of concentrated hydrochloric acid and nitric acid in the ratio of 3:1. This mixture is called aqua regia or royal water. It is highly corrosive and fuming liquid. So, and the goldsmith uses them. I will not go further now because I will recapitulate to you what is the dissolution of gold and platinum in aqua regia is due to the formation of newly born chlorine, which attacks the gold and platinum. So aqua regia का composition क्या है? 3HCl plus 1 HNO3, and when it reacts, it forms nitrosyl chloride NOCl plus 2H2O plus 2Cl, and then with this 2Cl which is released here, it reacts with the gold. Au plus 3Cl forms gold chloride AuCl3, and platinum plus 4Cl forms platinum chloride PtCl4. So this is the reaction of aqua regia. Very important. Water as aqua regia. What is the composition of aqua regia? Show the reaction of gold and platinum with aqua regia. I end my lesson here. And just before that, I just tell you about what I told today, that I started the lesson metal, non-metal. Pink one was metal, this one was non-metal. I started with the physical properties, then I started with the physical properties of metal, compared it to the non-metal. Then I started with the chemical properties of metal only. Non-metal I did not take. The nature of the oxides formed by a metal, the nature of the oxide of the metal, then the amphoteric oxide, what are they, how, give example, then metal with cold water, metal with hot water, metal with steam, and then some metals which don't react with steam, and the order of the reactivity. Order of the reactivity told you. Order of the reactivity I told you. What is the order of the reactivity? And then the comparison of sodium in water, calcium in water, magnesium in water. Why calcium floats in water? The reason. And then we came to. Then I came to amphoteric oxide. The example was of aluminium and zinc. They react both with acid and bases with those reactions. Then I came to sodium and potassium are very, very reactive metals, and why they are stored under water and kerosene, give their reaction. Then about magnesium, aluminium, zinc and lead, they also combine with oxygen at the room temperature, and what oxides they form, okay. And especially magnesium in this comparison, magnesium is most reactive than aluminium, then zinc, then lead, okay. Magnesium is the most reactive, then will be zinc, then will be first will be magnesium, then aluminium, then zinc, then lead, okay. Then we told about how iron combines with oxygen to form iron oxide, but the reaction, it doesn't burn even on strong heating, but it begins to glow with a bright light. That is why it is used in welding. Then I told you that how copper takes long time to form copper oxide. Then also told you silver, gold and platinum, they don't combine only with oxygen at room temperature. So this whole overall comparison was told. Then told you what is anodizing. Then told you the role of metal with water, sodium, potassium with cold water, calcium with hot water, magnesium with hot water, magnesium with steam, and then the aluminium, zinc and iron only with cold water. They neither react with hot, neither with cold, they only react with steam. These three, aluminium, zinc and iron. And then the experimental verification and the reactivity series in reaction with different metals in the reactivity series, which I told sodium, first was potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, silver, gold. Okay. Then we came to reaction with acid, sodium and potassium with acid. Calcium also reacts with acid, but less pronounced it is than sodium, potassium. Magnesium is quite rapid, but less as that to calcium. So aluminium reacts with acid and bases both, as I told you. And then copper, mercury, silver don't react with dilute acid or sulfuric acid, as already mentioned. And the order of reactivity told you same as the above. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, copper, silver, gold. In the end, I came to why nitric acid, no reaction with nitric acid. What is the role of nitric acid? Oxidizing agent. It is an oxidizing agent. What it does there, say if they ask you give the reaction Mg plus 2HNO3, you will write it forms magnesium nitrate and hydrogen. Magnesium nitrate plus hydrogen, because here the nitric acid is a strong oxidizing agent. It oxidizes the hydrogen formed into water, and itself it is reduced to oxide of nitrogen. Okay, this you will write. And then I came to gold and platinum, the noble metals. And then I came to what is aqua regia. Aqua regia ka another word is royal water, and the reaction. I hope I am clear with my lesson today, and try to read this much, verbally learn the lesson and write it. And thank you for coming back to this channel, because life is an adventure. We should keep on adventuring with new things, and wish you again happy Ganesh Chaturthi, and God bless you all, and meet you with the second part of the lesson very soon.